If you think we've mapped the solar system, here's the uncomfortable truth. We're still guessing what's lurking in the dark. Because beyond Neptune, the orbits of distant icy worlds don't behave like they should. They cluster. They tilt. They act like something massive is shepherding them from far beyond the reach of our telescopes. Astronomers call it Planet 9, a hypothetical world several times Earth's mass, on a path so vast it could take 10 to 20,000 years to orbit the Sun. And until recently, the problem was simple. If it's out there, it's almost impossible to see. At hundreds of astronomical units, sunlight is pathetic. A planet out there reflects almost nothing in visible light. So even if it's big, it's basically a black object on a black background. But heat is different. Even a frozen planet still leaks a little warmth as infrared radiation. And that's where the story just got interesting. In 2025, researchers stitched together two old, full-sky infrared surveys, IRAS in 1983 and Japan's AKARI in 2006. The surveys are separated by 23 years, enough time that a distant planet should shift slightly against the background stars. So they did something simple and brutal. They hunted for infrared sources that appear in both surveys, but move just a little, exactly the way a faraway planet would. After filtering and manual checks, one candidate survived. A faint infrared source that appears in both datasets, but not in the same spot. Over those 23 years, that source shifted by about 1.5 times the apparent width of the moon. That is not proof, it's a lead. But it's the kind of lead Planet 9 hunters dream about, because it's exactly what a first visible trace could look like at extreme distance. Then came the twist. Mike Brown, one of the scientists who helped popularize the Planet 9 hypothesis, looked at the candidate's implied orbit. And the numbers don't cleanly match the classic Planet 9 predictions. In its standard form, Planet 9 is expected to sit on a moderately tilted orbit, with a mass in the super-Earth range, far beyond Neptune. But this candidate, if the interpretation holds, could be tilted way more than expected. Meaning, it might not be Planet 9. It could be a different hidden planet entirely. And yes, the irony is perfect. The guy who spent a decade arguing for one invisible planet might end up staring at evidence for another one. If you remember the Neptune story, this is the same kind of game. Gravity first, image later. In the 1800s, Uranus didn't follow the orbit it should. Mathematicians worked backwards, predicted where an unseen planet must be, and astronomers pointed a telescope there. Neptune was found almost exactly where the math said it should be. Planet 9 is a modern version of that logic. Back in 2016, researchers showed that several extreme trans-Neptunian objects had strangely aligned orbits, not random, not evenly distributed, clustered in a way that's hard to explain with the known 8-planet system alone. The cleanest explanation is a distant massive planet shaping the outer solar system over billions of years. But cleanest doesn't mean true. There are alternatives, some mundane, some wild. One idea is observational bias. We detect objects in certain sky regions more easily, creating a fake cluster. Another is that the combined gravity of many small bodies could mimic a single planet. And there are more exotic proposals, like a primordial black hole with planet-like mass wandering out there. None of this is settled. That's the point. So here's why 2026 matters. A new machine changes the odds. The Vera C Rubin Observatory in Chile. Rubin revealed its first imagery in 2025 using the world's largest digital camera. And it's built for one thing that most telescopes are bad at: repetition. Instead of a few snapshots, Rubin is designed to produce a time-lapse movie of the sky. And anything that moves, asteroids, distant objects, faint, slow drifters, becomes easier to isolate when you have repeated observations. Rubin's own team says that in its first year alone, it will gather more optical data than all other optical observatories combined. And for the outer solar system, predictions suggest Rubin could expand the catalog beyond Neptune dramatically. Tens of thousands of new objects. That matters because even if Rubin doesn't directly photograph Planet 9, the orbits of those newly found objects will either strengthen the "something massive is sculpting this region" signal or destroy it. Rubin is not just a telescope, it's a constraint machine, and it's about to start acting like one. So, what happens next splits into two timelines. Timeline 1, Planet 9 is real. If Rubin finds a slow-moving point of light drifting exactly the way a 500 to 800 astronomical unit object should, it's not just a new planet. It forces a rewrite of solar system history. Because the outer belt likely didn't have enough material out there to build a super Earth on site. So either that planet formed closer in and got kicked outward during early chaos, or it's a rogue planet captured long ago from another star system. Either way, the outer solar system becomes less like a tidy map and more like a crime scene. Timeline 2, Planet 9 is not real. And honestly, that might be even more disturbing. Because then we still have to explain the outer object's weird architecture without the simplest culprit. Maybe the clustering was bias. Maybe there's a distributed population doing the work. Or maybe, in the most radical scenario, something about gravity at extreme distances isn't behaving the way our models assume. Rubin won't answer every philosophical question, but it can slam the door on easy excuses. It will either find the planet or map the region so well that the Planet 9 signal collapses under better evidence. And that's why this feels like a thriller. We've got a suspect. We've got an old infrared footprint. And now we're deploying a surveillance camera for the entire sky. So here's the bet. By late 2026 or 2027, we will likely know whether the solar system hides another major world, or whether the real mystery was the data itself. If you want the next layer, how modern AI pipelines are turning telescopes into automated discovery engines, and why old data plus new computation is now one of the most dangerous combinations in science, subscribe. Because the next discoveries won't arrive politely. They'll arrive as alerts.